All right, guys. 11.6, probability of independent and dependent events. All right, this one is one that I like, and I find a lot of use in it, and it makes a lot of sense to me. Hopefully it will to you after today. Learn to find the probability of independent and dependent events. Last week, one day, we had to tell if these events were dependent on each other or independent. Today, we use that. Raj and Kara must each choose a topic from a list of topics to research for their class. If Raj's choice has no effect on Kara's choice and vice versa, the events are independent. For independent events, the occurrence of one event has no effect on the probability of the second event. So, if once Raj chooses a topic, Kara must choose from the remaining topics, the events are dependent. For dependent events, the occurrence of one event does not have an effect on the probability that a second event will occur. Think about it like this. Got a bag of marbles. Got 5 blue marbles and 5 red marbles. If I draw into there, blue marble. I set the blue marble over here on the table. The next time when I'm looking at this, it changes my chances of getting a blue marble. So those two events would be dependent. One depends on the other or changes with the other. Now, let's say I have that same bag of marbles. 5 blue and 5 red. Blue marble, yay! Put the blue marble back in the bag. Notice that since I replaced it, those are independent. It doesn't change my probability at all. All right. So, decide whether the set of events are dependent or independent. Explain your answer. Kathy draws a 4 from a set of cards numbered 1 to 10 and rolls a 2 on a numbered dice. Is choosing the cards, does rolling the 2 depend on choosing the cards, or choosing the cards depend on rolling the 2? Neither do, so these do not depend on one another, and they are independent events. Drawing that card has no effect on rolling that dice, so they're independent. All right. Yuki chooses a book from the shelf to read, and then Janet chooses a book from the shelf to read. Did one of those depend on the other, or did it get changed by the other? And yes, it did. Because Janet cannot pick the same book that Yuki picked. So her choices were dependent on Yuki's choice. If they both wanted to read the same book and Yuki chose it first, Janet wouldn't get to choose it. So that's a dependent event where Janet's choices are changed by Yuki's. Okay? Joanne flips a coin and gets a heads. Then she rolls a 6 on a numbered cube. Does flipping the coin and rolling that dice, do they depend on one another? No! So they are independent events. Okay? Annabelle chooses a blue marble from a set of 3. Each of different colors. And then Louise chooses a second marble from the remaining 2 marbles. So we had the bag of marbles. Annabelle chose one. Then Louise gets to choose one. Did what Louise gets to choose depend on what Annabelle gets to choose? Yes, it very much did. So those are dependent events. Because Annabelle changed what Louise would get to choose from. To find the probability of 2 independent events that will happen, you multiply the probabilities of the 2 events. All right? Probability of 2 independent events. Probability of A and B. The probability of both events happening has to be multiplied. Okay? Equals probability of A times the probability of B. They're going to be in fractions. That would be my suggestion. So, the probability of choosing a green marble at random from a bag containing 5 green and 10 white marbles, then flipping a coin and getting heads. So, we have to think how many marbles are in the bag. There were 5 green ones and 10 white ones. Oh, there's 15 marbles in the bag. So that's my total marbles, right? Then, find choosing a green one. 5 of them were green, so there's a 5 out of 15 chance of reaching into that bag and grabbing a green marble out, right? Then what is the probability of flipping a coin and getting tails? Well, one of the sides of the coin is tails and there's two sides. Oh. This is probability of A. This is probability of B. We multiply. And yes, you can reduce. 5 over 30. 5 times 1, 15 times 2. 1 out of 6 is your probability. Okay? The outcome of choosing the marble does not affect the outcome of flipping the coin, so the events are independent. So, what's the probability of green and tails? Well, let's look at the probability of getting a green one. All right, probability of getting a green one was 5 out of 15, or 1/3. Those are the same number. Probability of getting tails is 1 out of 2. We multiply those, and we get 1/6. Whether you reduce first or reduce at the end, it does not matter. You still get the 1/6 like I showed or the 1/6 like they showed. Okay? So, find the probability of choosing a red marble at random from a bag containing 5 red and 5 white marbles. So there's 10 total marbles, and they want to know probability of getting a red one. That's 5 out of 10. And then flipping a coin and getting heads. Well, there's two sides to the coin. One of them is a head. I can multiply those two because that's the probability of one, probability of the other. So that'd be 5 over 20, or 1/4. Okay? Those two events are independent, so we can use what they told us. Probability of getting a red is 5 out of 10, or 1/2. Heads is 1/2. We multiply those and we get 1/4. Same answer as I did. Now we switch gears. To find the probability of two dependent events, you must determine the effect that the first event has on the probability of the second event. Probability of two dependent events. You're still going to multiply them. Probability of A times probability of B after A. And let's think about it this way. A reading list contains 5 history books and 3 science fiction books. What is the probability that Juan will randomly choose a history book for his first report? Well, there were 8 total books, and 5 out of 8. That was his chance of choosing a history book for that first book. And a science fiction book for his second book. So now we've got to think. All right, the first time, yes, there's 8 books here. I pick up one. Yeah, I got the history like I wanted. Now I put that book over here in my backpack. How many books are left here? There's no longer 8 books here. There's 7 books. Now, out of those 7 books, since I took one history book, how many science fiction books are there still? There are still 3 science fiction books that I can choose. So, do you see how that first event depended, what made the second event dependent on it? Oh, so 15 over 56. And then we can look to reduce if that's possible, and I'm not seeing that it is. So 15 over 56 is what I see as the answer. Let's see if we get it right. Okay. The first choice changes the number of books left and changes the number of science fiction books left. So the events are dependent. So there are 5 history books out of 8. So that's 5 out of 8. There are 3 science fiction books out of 7 that are left. So that's 3 out of 7. So we take 5/8 for the history book times the 3 out of 7 for the science fiction books. We multiply those and we get 15 out of 56. That is our probability of getting that. And we know we could always change it into a percent, but there's no need. Okay. Alice has been dealt a hand of cards consisting of 4 black and 3 red cards. Without seeing the cards, what is the probability that the first card will be black and the second card will be red? So we want to know, we want to get a black card when I'm drawing them randomly out of her hand, and then I want to get a red card. Well, let's think about the probability of getting a black card. She has 7 in her hand, and 4 of them were black. So I have a 4 out of 7 chance. Black card! Yes, good. Throw it over there. Now, since I took that 1 card already, how many cards are left in her hand? Just the 6. How many of those are red? Oh, she got black the first time. That didn't change that. 3. 3/6. All right. I'm going to reduce before I multiply because that makes the problem much easier. Divided by 3 on each side. So that would be 1 over 2. Then I divide it by 2 and 2, as long as both numbers are on top and bottom. All right. So then I get 2 out of 7 as my probability of getting that. Or we could have done this and had 12 out of 56 and divided both by 6. You can do it that way too. All right. No, not divided both by 6. Oh, 4. Yeah. All right, we could divide both by 4. And that would be 3. And that would be 1/14. Oh, 3/14. Looks like I made a mistake somewhere. 3. Well, feathers. That's not going to be good. All right, let's go ahead and see where I made a mistake. Looks like 3/14 or 2 7s. I am sorry that I messed that up. All right, 4 7s was correct. 3 6 was correct. All right, we multiply those two. And we get 12 out of 42. Oh, 7 times 6 is 42, not that. And it is 2 7s. So what I did earlier. I just multiplied wrong in the second one. So 2 7s is your chance of getting a red than a black card. Okay? Remember, think about what you had. Oh, I removed that first one. Think about what's left. Then you multiply the fractions. All right, guys.